My name is Renee, and in today's science segment, we'll be exploring air and gravity by making your own toy parachute. The first thing we'll start with today is learning about air and gravity. Now, all objects attract other objects because of a force called gravity. Gravity is a pulling force that works across space. That is, objects do not have to touch each other for the force of gravity to affect them. On Earth, gravity pulls objects towards the center of the Earth. This is what makes objects fall. It is also what gives an object weight. Weight is a measure of the force of gravity pulling on an object. So, you may be wondering, does that mean heavier objects will fall faster? Well, I'm going to answer this question by telling you a little story about Galileo Galilei, who was a famous Italian physicist and engineer, among many other things. A long time ago, in about 1590 as the story goes, Galileo Galilei went to the top of the Leaning Tower of Pisa and dropped many pairs of items at the same time. He used things such as cannonballs, gold, silver, and wood. In each trial, one of the objects was heavier than the other, but they were both the same shape and size. What he discovered was that they both hit the ground at the same time. Now this was contrary to what Aristotle, the Greek philosopher and scientist, had taught, that heavier objects fell faster than light objects. But Galileo determined that gravity accelerates all objects at the same rate, regardless of their mass or what they're made of. Now, I'm going to show you a few demos so that you can really understand Galileo's discovery about gravity. First, I'm going to drop a ping pong ball and a golf ball from the same height. I want you to pause the video here and make a prediction about which ball will reach the ground first. Next, I'm going to drop a piece of paper and a piece of cardboard. I'm going to scrunch up the piece of paper, which is lighter than the piece of cardboard. Like before, I'm going to drop them both at the same time from the same height. Again, I want you to pause here and make a prediction about which one will reach the ground first. So, what happened here? Well, resistance and friction are what cause changes in acceleration. Acceleration is the rate of change of velocity, or how fast an object or person speeds up. Air resistance, also called drag, slowed down the heavier piece. Air resistance opposes the direction that the object is moving and slows it down. Air resistance happens because objects bump into lots of air molecules as they fall. The air molecules get knocked away and take some of the kinetic energy away from the object, which makes the object slow down. So, regardless of weight, the more resistance or friction an object has, the slower the fall. Finally, I'm going to drop a rock and a feather that are about the same size. Again, I want you to pause here and make a prediction about which one will reach the ground first. The heavier rock will land first, but not because it weighs more, as you've already learned. There is more friction between the feather and the air around it. The rock was not slowed down as much as the feather by the air molecules. If we could drop the feather and the rock in a vacuum, which is a space without any air, they would both hit the ground at the same time. The experiment of dropping things in a vacuum has actually been done, and it has shown that the objects do fall at the same speed. Now, to slow down the fall of an object, you'll want to create more air resistance. That's the goal of a parachute. It's also why feathers make better parachutes than rocks. Sometimes, people will use their knowledge of air resistance to design things to move faster or slower. The noses of airplanes are designed to cut through the air, which is another way of saying they have low air resistance. On the other hand, parachutes are designed to have lots of air resistance and to fall as slow as possible. This leads me into our second topic of the day, which is the history of parachutes. An early idea of a parachute was found in a manuscript from the 1470s, long before Galileo was dropping objects from the Tower of Pisa. It wasn't the best design because the parachute did not have enough resistance, but the design introduced a new idea to artist engineers of the times. A few years later, Leonardo da Vinci, who was an Italian painter, architect, and engineer, among many other things, sketched a similar and improved design. Most people give Da Vinci credit for the concept of falling safely using what he called a maximum drag decelerator. This concept wasn't new, however. The use of air resistance to slow down a fall can be dated back to 90 BC. There's actually a legend of an emperor using two bamboo hats to jump off a roof and land safely on the ground. By the way, do not try these stunts at home. There are other stories based on legends about parachutes that date way before Da Vinci's design. Parachute designs continue to evolve and be tested. Parachutes today are used to move troops or equipment into position in war zones, deliver goods, save lives, decelerate or slow down aircraft, and, as you probably know, for the sport of skydiving. The simple idea has evolved into an amazing invention that can be steered and manipulated almost like an airplane, just by using lift, drag, and gravity. Now that we know all about the history of parachutes and the forces acting on parachutes, we can now get into creating our own toy version. For this activity, you will need a dinner napkin, yarn or string, but yarn usually works better than string, scissors, a pencil, a small lightweight figure. Some examples include Lego people, army figures, superheroes, Littlest Pet Shops, Polly Pockets, and etc. And you can also use markers, but this is optional. First, you're going to open up your napkin. If you want, you can decorate your parachute by drawing on the napkin with markers. It's best to use a chunky or soft tip marker so that you can avoid making tears in the napkin. Next, you're going to flip the napkin over and measure your string or yarn a length and a half of the napkin. You're going to want to cut 3 more pieces of the same size. Then, you're going to poke a hole at each of the 4 corners of the napkin using your pencil. Next, you're going to loop a piece of string through each of the 4 holes you made and carefully tie a knot. Once that's done, you're going to pull all of the strings together and at about 35 to 40 centimeters in, tie one big knot. You want to make sure the strings are all equal in length so that the corners are the same height. Then you're going to use the remaining strands to secure your figure. And then you can cut off any remaining strands. Now is the moment you've been waiting for. Your parachute is finally ready to test. And just a quick warning, please be careful, but the more height, the better. It is helpful to pinch the top and then let it go. If you run into trouble, make sure the strings aren't tangled and the napkin isn't too crumpled. You can try throwing the parachute from different heights, and you can also try using different figures. If you want, you could also take a paper or plastic cup, punch a hole on each side, and then secure it to the string to make a little cup for the figure to ride in. So, to recap, what did we learn today? Well, we explored the concepts of air and gravity, we learned about the history of parachutes, and we even got to apply what we learned by making our own toy parachute.